Morning, students. Today we are going to see the subtopic of Unit 3, Risk of Irreversible Changes and Introduction to Linkage between the Climate Change Adaptation and Development. Coming to the risk of irreversible changes, what is irreversibility? Irreversibility, for example, if you take a rubber band and you just try to pull it, stretch it to a longer length, obviously it will break. It will break. Okay, so the breaking point again you could not regain to back to its original position. So irreversibility are changes that need to be taken. Is seriously viewed. Okay, so introduction to irreversible risk not coming back to the position. So that risk, what are the why this is, what are the things we need to take care of? The climate change impacts on freshwater resources are profound, are depth, and in some cases irreversible. Okay, so we could not come back again. Okay, so that's a scenario. The freshwater resources are very profound in depth. Observational records and projection confirm vulnerability across ecosystems and societies. So the record shows that it has a vulnerability across different parts, even for the human ecosystems and societies. Irreversible impact occur when thresholds are crossed. When the level has been threshold, the maximum regaining position, the plasticity above the which what will happen? The plastic, the rubber band will not come back to the original position, it will break, right? Similarly, the threshold, it crosses the threshold, leading to permanent or very long-term changes. So irreversible impact is very cautiously we need to be viewed. Understanding the risk is crucial for adaptation planning as societies cannot always reverse damage once systems collapse. This lecture highlights the major irreversible risk and explain the connection between the adaptation and sustainable development. So coming to the definition of abrupt climate change, abrupt climate change refers to rapid non-linear shift in climate systems. Occurs faster than the time scale of forcing responsible, not always externally driven, some arise from internal system instabilities, can produce surprises such as sudden temperature shift, circulation collapses, and unexpected drought. You may get a very heavy rainfall or a drought may take place. This even challenge adaptation planning since they cannot be predicted smoothly through the gradual models. Coming to the loss of glaciers. So many small glaciers in Bolivia, Ecuador and Peru are expected to vanish within decades. So you could not regain back. Okay, so regain back the situation after you it's not in, by nature only can create a glaciers. Okay, glacier basins, the snowfall. Okay, so if there has been lost, the people we have been depending on this particular fresh water from glacier basins. Okay, just imagine the people will be getting affected. Small glaciers will vanishes. Okay, you can it will not come back. Himalayan and Hindu Kush glaciers are critical, supplying water to millions in China and India and Pakistan. So the glaciers which have been present in the Himalaya and the Hindu Kush supplying water to millions of people in China, India, and Pakistan. Loss of dry season glacial meltwater threatens agriculture, drinking water, and hydropower. Once lost, glacier cannot be restored. So that's why I told you. So in regain, we could not able to regain the situation. Okay, within you, glacier cannot restored within human time scales. This represents one of the most visible irreversible water-related climate impact. So we cannot come back to the initial position, irreversible. Okay, ecosystem shift and extinctions because of the climate activity, climate change, large scale climate changes disturb the marine and terrestrial ecosystem. So we know already we have seen actually the climate change how it affects the marine life in a extensive way. The collapse of meridional outturning circulation could alter fisheries, carbon dioxide uptake, and oxygen balance. What do you mean by meridional outturning circulation? This need to be explained with the diagram when you try to explain about meridional outturning circulation in exams. This need to be referred with the what you call please draw the diagram and explain about it. So I didn't show to you these images because of the copyright issues and things. Okay, so the meridional overturning circulation refers to large scale ozone current that transport heat, salt, and nutrients north south within ozone basins and globally, acting like a giant conveyor belt. The Atlantic meridional overturning circulation, acronym as AMOC, Atlantic Meridional Overturning Circulation, is the most well-known example. Circulating warm surface water to the North Atlantic, where it cools, sinks, and returns south as deep water, significantly influencing global and regional climates. This circulation system is important for redistributing heat around the planet, and changes in its strength or stability can have major impact on Earth climate and ecosystem. The AMOC, the meridional overturning circulation, how it works. Process, this AMOC process involves several steps, primarily driven by temperature and salinity variation. Warm water transport, warm salty water from the tropics flow north in the upper ocean of the Atlantic, cooling and sinking. As this water travels north, it cools and becomes saltier due to evaporation, increasing its density. Deep water formation. This cold, dense water sinks into the ocean depth in the North Atlantic. Southward flow, the sinking water then spreads out along the seafloor, forming a deep, cold current that eventually rises back to the surface to complete the cycle. The significance and climate impact, heat distribution, nutrient and gas exchange, and climate regulation. So, material overturning circulation, please try to understand, okay, what is happens, how it alters the fisheries, carbon dioxide uptake, and oxygen balance. Freshwater ecosystem face the highest extinction risk with the species poorly adapted to rapid warming. Terrestrial vegetation zones may shift permanently, threatening the biodiversity. Conservation practices remain inadequate, often unable to keep pace with rapid climate driven changes. Threaten to unique systems. So, climate change threatens biodiversity hotspots and unique ecosystems. The coral reefs are highly vulnerable due to low adaptive capacity. So the coral reef that you have jellyfish or something which has been floating okay very close to the seashore, this need not be migrated or this not be disturbed because the ecosystem if it is getting disturbed, the whole thing I mean even the human will be getting affected in turn. Okay, so the sea surface temperature increased to 1 to 3 degrees Celsius, trigger bleaching and mortality events. Coral loss reduces coastal production, fisheries productivity, and marine biodiversity. Okay, so this all threat to the unique systems. Without rapid adaptation or mitigation, such system may be lost permanently. So just imagine. So you may think of if a coral reef vanishes. Okay, if it is subject to think what is the big deal with the human? Because this reduces the pattern. I mean, because if it vanishes, okay, because of the climate change, obviously the fisheries productivity and the fish will migrate. All these things will happen. The temperature of the water will increase. Okay, so this all will leads to a different situation that will not be regained back. Exceeding adaptive capacity, climate change may surpass the adaptive capacity of natural and human systems. So the adaptive capacity may surpass the adaptive. That means that will the adaptive capacity is certain level. Okay, if it is increase the threshold, I mean reversible condition. Beyond certain threshold, adaptation becomes ineffective or prohibitively expensive. Just now I told you, right? Adaptive become ineffective and prohibitively expensive. Poorer regions may face several social, economic, and environmental cost, over reliance, and adaptation without mitigation risk reaching points of no return. The timing of these limits varies across sectors, but evidence shows some systems are already near their thresholds. So it's an alarming situation. So if it is very close to this threshold, if it is go beyond the threshold, we could not regain back to the normal situation. It's out of control. Threshold and system shift. Climate systems may abruptly transition when thresholds are crossed. Example, sudden collapse of glaciers or abrupt ecosystem die-offs or hydrological cycle shift. Threshold-driven impacts are difficult to reverse as feedback loops reinforce new states. Identifying such vulnerabilities helps prioritize adaptation strategies. Threshold analysis provide early warning signals for irreversible risk in water, ecosystem, and human systems. Threshold analysis provide early warning signals for irreversible risk. Okay, so irreversible risk is very need to be taken care of. If it is going beyond this threshold, you cannot regain back to the normal. If glacier disappears, we could not able to build the glaciers. Hope you understood what I'm trying to say. So obviously, the people who have been depending on the fresh water from the glaciers will be affected. So millions of people in the Himalayan areas and in India, in China, as well as in Pakistan, depending on the fresh water from the glaciers. So that we have seen already, right? So introduction to adaptation, development, linkage. Climate change and development are deeply interconnected. Impacts on freshwater resources affect poverty reduction, food security, and health outcomes. Okay, development pathways influence adaptive capacity by shaping resources across and governance equality. The Intergovernmental Panel on Climate Change stresses that understanding these linkages helps design policies that address both climate adaptation and sustainable development. So all these policies have been made for the sustainable development and also try to reduce the climate change. Okay, so and then increase the capacity of the adaptation at the same time trying to reduce the irreversible risk. Okay, so effective adaptation must be integrated with the long-term development goals. Vulnerability defined. So how to what is vulnerability? Measures how exposed and sensitive systems are to climate change. Is a sense of how it has been exposed. Okay, determined by three factors: exposure, sensitivity, and adaptive capacity. This we have already discussed in the previous lectures. And adaptive capacity is the ability to adjust and cope up with the climate impact shaped by resources, institutions, technology, and governance structures unevenly distributed across countries and communities, creating inequality. Strong adaptive capacity reduces vulnerability and enhances resilience. Weak capacity, especially in developing nations, leaves societies exposed to irreversible damages. So, adaptive capacity you need to enhance, okay, in order to avoid the irreversible damages. Socio and economic stresses, vulnerability is amplified by poverty, poor governance, and inequality. Food insecurity, lack of health care, and diseases such as HIV and AIDS weaken resilience. Economic globalization often creates uneven benefits, leaving weaker groups exposed. Conflict and migration further stress adaptive systems. So you may say actually the adaptation for a poor country is very low because they may are subject to irreversible changes. But it's not only for the poor country. The region which has been surrounded by us, the poor region, I also a rich region may get also get affected. So the climate is a universal global one. Okay, so we need to uplift these things for our own benefit, and even the countries which have been considered as a wealthy nation. Addressing these issues is a key for reducing the climate vulnerability alongside adaptation measures. Climate change and sustainable development, freshwater impacts of climate change undermine the progress towards sustainability, poverty reduction, child mortality reduction, and food security goals are threatened. Increased floods and droughts directly impact livelihoods and infrastructure. Climate change interacts with other challenges, multiplying risk to development. Without addressing these interlinkages, sustainable development becomes harder to achieve. So, interlinkage we need to address, okay, for the sustainable development. That's what they try to say. Okay, so please try to understand what for we are studying all this. Okay, in order to avoid the irreversibility. Okay, because even the vulnerability and adaptive capacity, um, eh, adaptive capacity even if it is a high, if it is go beyond this threshold, okay, because of the vulnerability, what will happen, the irreversibility will comes into picture. So poverty and weak governance limit adaptation options. Many low income nations lack financial resources for climate resilient infrastructure. Forced resilience on sustainable practices such as groundwater over extraction worsen risk. Limited institutional capacity restricts implementation of long-term adaptive strategies. These nations remain most vulnerable to irreversible changes. So low income countries are subject to the things because of the low adaptation capacity. Okay, so risk to development pathways, sustainable development goals and millennium development goals, it hinders the achievement of SDGs as well as millennium development goals. So climate change can derail the national development agendas, unaddress the impact, lock vulnerable nations into cycles of poverty and resource scarcity. Integration of adaptation into development planning is critical to avoid setbacks. Without action, progress made in decades of development will be undone. So just imagine a country has been developed and there is a lot of, I just given a scenario. Now, right now, there is a Israel, Iran conflict and the Palestine. The people have been bombing the Palestine or bombing the Iran. Okay, just imagine it has been constructed. So once you bomb, okay, that is to come back to the situation, how long it takes. Sometimes what will happen if you have been if it is a nuclear war, that's all finished already, right? So the vulnerability, what I mean, the irreversibility. For example, the land has been um, uh, bombarded with nuclear weapons. Obviously, it will not regain back. So you might have seen actually what happened because of the little boy and fat man in Japan during the Second World War. Okay, so if this is happened, you could not regain back. So it's something like that. The climate, if you have been not taking care of the climate change very keenly, the irreversibility could not reversible situation could not happen. Okay, so irreversibility risk is the very important parameter that need to be taken care of. Hope I just give an example to the real scenario. Okay, hope you get an idea. Okay, what I'm talking about. Adaptation strategies. Adaptation must be aligned with the development, environment, and health policies. Strategies should reduce both current vulnerability and future risk. Example: improved water management benefits both adaptation and development. Incorporating traditional knowledge with modern science strengthen the adaptation. Holistic planning ensures that strategies serve multiple social and environmental goals simultaneously. Sustainable development means as adaptation. So we need to go for adaptation for sustainable development. Making development more sustainable enhances climate resilience. Okay, sustainable development reduces emission, increases adaptive capacity, and lowers vulnerability. So, sustainable development goals, the 17 sustainable development goals have been found by what you call has been United Nations. Okay, the people have been working for that. Okay, they like what you call it, poverty, no hunger, and so on and so forth. Okay, so similarly, the sustainable development reduces the emissions, okay, increase adaptive capacity and lowers vulnerability. Policies that integrate adaptive strengthen long-term growth. Example: climate smart agriculture improves food security while cutting emissions. Sustainability serves as both as mitigation and adaptive adaptation pathway. So mitigation and vulnerability that we have seen in the last test. Okay, sustainability serves as both a mitigation and adaptation pathway. Learning from climate variability, past responses to climate variability provide lessons for adaptation. Communities have historically adapted to drought, flood, and changing weather. Incorporating such experience into governance builds resilience. Scaling lessons from local to global level is a key for considering adaptation. Learning oriented adaptation reduces the risk of maladaptation. Okay, coming to the adaptation and mitigation interaction. Adaptation and mitigation are complementary, not substitute. Adaptation reduces vulnerability to impact already locked in. Mitigation prevents long term irreversible changes by reducing the emissions. Early mitigation avoid high cost adaptation in the future. Integrated strategies maximize the benefit for both current and future generations. Policy synergies. So the policy synergies will help you to reduce the risk of irreversibility. Mitigation actions like renewable energy improve adaptation by reducing the pollution and enhancing the resilience. Forestation restores ecosystems. So we need to go for afforestation as we talked about 35% of greenery. Okay, so and you should not deforest the things because of that the climate change pattern happens. the rainfall will get affected, and because of that, obviously the ecosystem will be vulnerable. So obviously, because of the climate change, what will happen? Um, the reversible situation happens. So the people, it will not be, land will not be suitable for living. I mean, the earth will not be suitable for human living, not only for human, even for the other species as well. So adaptation measures like desalination or pumping can increase the energy demand, raising emissions. Integrated land and water management avoids conflict across sectors. Policy must evaluate trade-off to balance the adaptation and mitigation effectively. So the policy is supposed to trade off between the adaptation and mitigation. So you know what is adaptation, what is mitigation. Adaptation, mitigation is try to reduce and try to bring the level to a sustainable development. Adaptation just adapt to the situation by means of the technology or the available resources or knowledge. But adaptation is not a final solution, but the mitigation is very very important to have a sustainable goals. Unless you have a sustainable system, it's very difficult to our go for a decrease in climate change. If there is no decrease in climate change, obviously the modeling shows alarming predictions which need to be taken care of. Okay, and that will lead to a irreversible situation. Okay, please keep in mind. Okay, coming to the conclusion of integrated pathways, irreversible risk highlight the urgency of both adaptation and mitigation. So mitigation is not only the solution, we also need to go for adaptation. Mitigation is more stronger when compared to the adaptation. That's what I can put. Development pathways determine the society's resilience to climate stress. Okay, strengthening adaptive capacity requires government reform, resource equity, and sustainable practices. Adaptation and mitigation must work together to reduce risk. Underline the word work together. As I told you, even though the adaptive mitigation is very strong correlation when compared to the adaptation, but mitigation and adaptation supposed to go together for a sustainable development. Integrated forward-looking strategies offer the best chance to protect societies and ecosystem from irreversible climate damages. So with this note, I conclude today's lecture. We are ending up with one more subdivision in Unit 3 that I will take you very shortly. Thank you for your listening. Thank you. If you have any doubt during face-to-face section, we will clarify. We will discuss, and I will try to clarify your doubts. Okay. Thank you. Thank you for your attention.